Today we are going to talk about Chapter 3, Elements and Compounds. Section 3.1, the periodic table, classifying the elements. The periodic table. Dmitri Mendeleev is considered to be the father of the periodic table. He created the table based on atomic masses. Here is an example of the first periodic table that Mendeleev came up with. Notice that he came up with groups and rows. He proved that missing atoms can be predicted. So he set it up based on the atomic masses, and where an element didn't fit into a group or a row, he left those areas blank. And he said that those elements just had not been discovered yet. And it was found years later when they came up with the periodic table that we have today, that those spaces that he left blank were filled in with elements that correctly fell into his patterns of his rows and his columns. So this is the modern periodic table. The modern periodic table is divided into three main sections. The metals are the elements to the left on the periodic table. The nonmetals are to the right of the periodic table. And this group of elements right here separates metals from nonmetals. Those are called metalloids. There is a thick black line on the periodic table that you will see. An element whose border touches that black line is considered to be a metalloid. Okay. Notice that the metals consist of the main chunk of the periodic table. There are some special parts to the metals or special subgroups of metals. This group right here, I think it goes over in a second. This group right here, they are called the transition metals. You will notice that there's always these two rows down here that you always see. These rows actually go in right here and right here. So you kind of have to think about pulling those elements apart. Actually, they go right here, right here. You have to think about pulling those elements apart and sticking these two bottom rows in there. The reason the two bottom rows are always put on the bottom, though, is that if they were put in their proper space, the periodic table would be way too long or wide to put in a standard textbook. So it's conveniently, it's made convenient by putting them on the bottom there. Okay. On the periodic table, the vertical columns are called groups. So these guys are called the groups. And the horizontal rows are called periods. Metals versus nonmetals. So there are distinct characteristics that categorize metals, and there are distinct characteristics that categorize nonmetals. These are some examples of them. And in class, you will have a chance to categorize them on your own. You can press pause if you would like at this point to kind of quiz yourself to see if you can put these characteristics into either the metal or non-metal category. Okay, so metals are usually solid at room temperature with high melting and boiling points. They are hard and dense. They are good conductors of electricity. They are good conductors of heat. They are malleable and ductile. Malleable means that if you took a hammer and hit a metal, it would pound into a thin sheet. Ductile means that if you heat a metal up and then pull the metal out with both hands, it will pull into a thin wire. So it means that metals are sort of bendable and flexible. Mostly gray in color. Nonmetals can be solids, liquids, or gases at room temperature with low melting and boiling points. They are softer than metals with lower densities. They are poor conductors and good insulators. They have poor heat transfer. They are brittle, which means that if you took a hammer to a nonmetal, instead of being flexible and pounding, it will shatter and break. And they vary in color. Metalloids have properties of both metals and nonmetals. They are not great conductors of electricity or heat. Somewhat brittle, but malleable as well. They are gray in color. This is a picture of silicon. This is a picture of boron, and this is a picture of antimony. The transition metals are those groups of metals in the bottom sort of valley of the periodic table. They kind of have their own rules. So when we talk about the metals, as far as valence electrons and patterns go, we are usually referring to the main 5 groups on the periodic table. The transition metals have their own sets of rules and things later on we'll talk about. Electron arrangement. Notice the elements in the same column and group all end with the same number of valence electrons. So here in group 1, this 2-1 tells you that in the first shell there are 2 electrons, in the second shell there are 1. Notice that all the way down group 1, they all have 1 valence electron. In group 2, notice that the outside shells all have 2. In group 3, they all have 3. In group 4, they all have 4. In group 5, they all have 5, and so on and so forth. Remember, for the noble gases, they all have 8, except helium, which is that exception in the noble gas group. Mendelev's table. While it was the first periodic table, Mendeleev had very different elements, such as the really reactive potassium and the very stable copper in the same family, because he based his periodic table on masses. 40 years later, Moseley rearranged the elements by their atomic number, which gave the table a better periodicity. So there was a better pattern and matching of reactivities when Moseley arranged them according to their atomic number. Short form of the periodic table has these last 2 rows called the lengthenide and actinide series pulled out. If you were to put them in their proper form, this is what the long form of the periodic table would look like. And again, it just isn't convenient for textbooks and print to put those 2 rows in there, so they are pulled out towards the bottom. Interesting fact, no matter what language the periodic table is written in, the symbols are always in English. So this is the Chinese periodic table. Notice that the symbols are always English Arabic numbers. Periods run horizontally. All elements of a period have the same number of valence energy levels. All the elements from rubidium to xenon have 5 energy levels, for example. Families, also known as groups, run vertically. All elements in a family have the same number of valence electrons, which determine an element's chemical and physical properties. The groups on the periodic table, some of them have special names. Group 1A are called the alkali metals. They are lithium, sodium, potassium, rubidium, cesium, and francium. Group 2A are called the alkaline earth metals. They're less reactive than the alkali metals, but more reactive than the other metals to their right. Just going back to the alkali metals, notice that hydrogen is not included as an alkali metal. The transition metals are those metals in that bottom valley that sort of separate the left and the right towers of the periodic table. Group 3A is called the boron family, so there's not like a special name to that, it's just named based on the first element in that group. The carbon family, which is group 4A, contains a wide variety of elements. It contains a nonmetal, carbon, 2 metalloids, silicon and gallium, and 2 metals, lead and antimony. So it's probably the most diverse family as far as containing different types of elements like that. The nitrogen family is group 5A. Nitrogen, phosphorus, astatine, antimony, and bismuth. The oxygen family is group 6A. Oxygen, sulfur, selenium, tellurium, and polonium. The halogens, so group 7 has a special name. They are called the halogens. They are the most reactive nonmetals. fluorine, chlorine, bromine, iodine, and astatine. And then the noble gases are group 8A, the inert non-reactive gases of helium, neon, argon, krypton, xenon, and radon. Metallic properties. Metals are silver in color and have luster, solid at room temperature, have high densities, are malleable and ductile, are good conductors of heat and electricity. Atoms have between 1 and 3 valence electrons. Atoms have a loose hold of their valence electrons. They give their electrons up easily, and they corrode or rust in the presence of oxygen. And we will stop there for today.